Hello, my name's Bob Willis, and every month we show you how to do it. In this issue, we're going to talk about open circuits on area array packages. Now, if you suffer from open circuits, or you have a problem and you believe it's the area array package, then we have to do a number of things. Now, first of all, it's good to establish if there is a defect, and we can first of all do this with electrical test, potentially. The next thing we should consider is the use of optical inspection to inspect all the terminations around all four sides of the package. Also look at the standoff height of the package on the four corners and also in the center areas. Now, optical inspection allows you to see the potential for opens, and it also allows you to see whether or not there is damage to the pads connecting to the PCB, or whether it's a solder joint failure. Now, sometimes you can't see all joints with optical inspection. This is why we go to X-ray. Now again, X-ray as a technique is extremely valuable because we can obviously look for the obvious faults like short circuits. We can look for poor wetting, open circuits, and with wetting indicators we can see the degree of wetting which is present, but that's designed into the design from the start. So you have to consider this right at concept stage. Now again, X-ray inspection allows you to measure ball size. Now a lot of engineers miss out on this opportunity. Now, measuring ball size, particularly at the MPI build, allows you to assess the performance of a product and process, but then again it allows you to have a comparison you can measure against subsequent batches. Those are the two common techniques. Now, there are other techniques to look for open circuits which are unfortunately destructive. We can look at microsectioning. Now, microsectioning allows you to mount a sample and to look at every row of individual terminations until you find the point of failure. Now, this can be time consuming, and of course it needs the skill of a metallurgist to understand the changes in the materials. But at least you can go from termination to termination. We can also do die and pry. Now, die and pry allows you to see the interface of failure, and sometimes that's perhaps more beneficial than doing a microsection. Now, die and pry, basically we're introducing a die into and around the termination points on a BGA board. That die will penetrate into any cracks, any open circuits, and will stay on the surface when you mechanically remove the component from the printed circuit board. So what we can actually see is where the failure has occurred, and then attribute blame to the process, the package, the substrate, or mechanical damage caused by usage of the product, or handling, or transportation of the package from customer to customer. So again, understanding the failure mode of a BGA with open circuits can use a number of different techniques. It's picking the right technique which gives you the maximum amount of information for the effort spent.